All right, great, great. Okay, so today is going to be the last session. All right, and please feel free to ask questions, and I'll ask questions related to the topics that we discussed yesterday or which we are going to discuss today. All right. Oh, all right. So basically, yesterday and today is same thing. Oh, what we have? Okay. So all right. So we have already discussed what we discussed yesterday on 15th, session 15. So the same thing as yesterday. And the video of yesterday is available in 17. And video for today will be available here. Okay. So the Ravi, can you see my screen? In session 15 and 16 are those two sessions. Okay. On Feb 28 and March 1. These are those two sessions that we had. And session 17 is from yesterday, and session 18 will be from today. This will get updated. All right. These titles are a little off, so I'll have to fix these titles because there has been some changes in plans. So I'll have to fix these titles. But most of the things you will find in these slides and the videos. Okay. I mean, the YouTube does not provide downloading these videos. And yeah, the YouTube does not. So you can use YouTube downloader sites, keepwith.com or something. There are many YouTube downloading websites, and which can allow you to download these videos. Okay. All right. So another question from Ravi is, normally the rest are somewhere else. I could download fine, but these are the ones I could not find. Are you able to find these now? So from 15, 16, 17. No? Okay. Please check and let me know, Ravi. A question from Degu. I have a question. If we have many server and every server has Apache log, okay, can we use Spark like in Weblog project to analyze all of the Apache logs and group the result as one result? Yes, definitely. Yes. So, okay, let me try to answer the specific question which Tegu has asked. Okay, let me just draw it. Probably that will help better. So the Ravi, the YouTube does not allow downloading. You'll have to use these third-party tools like Keepwid or some other plugins to start downloading, because it doesn't. We don't have uh, any control over what it allows. Okay. But personally, I don't have a problem in you downloading them. Okay. Just that you'll have to use Keepwid. I think Keepwid does the same thing. So you just find out the URL of YouTube, and then you could. Yes, these are recorded in the same way as earlier. Okay, you can see that these are recorded in the same way, and they're all hosted on basically YouTube. To avoid restrictions, we are using YouTube so that our students do not face any kind of problems. And so what you can do is you can take the URL from here. You can take the URL, and there are these third-party tools. Okay, so you can see keep, wait, and there was some tool for keep feed here. So from keep feed, you just put the URL. It will give you the download option. All right, you can see that. So there are these third-party tools that you can use. All right. So did I make sense, Ravi? The reason why we are using YouTube, not somebody else, because one, YouTube is accessible on all devices, and we have had a very good successful thing using YouTube. We have tried other options as well, but they were more restrictive to the students. They were more restrictive. Therefore, we are using YouTube. Okay. So just search for keep fade. I think that one works well. Okay. This one, this website should help you in downloading the video. All right. Good. Did I answer your question? So all of these are aggregated together. Every session's video is available uh, in that particular tab. You can see Gen 14, Gen 14, and Gen 15, Gen 15, and so on. Okay, so you should not face any problem in finding the videos. And yeah, regarding the title of every session, that I'm going to fix maybe tomorrow or afterwards. Ah, okay. So Ravi's point was, yeah. So that is something I would say that, yeah, this is one drive. It's hard to keep it updated because this is, I will update it later. Okay, but the more important is this session 17. Okay, I'll try to upload it there. Okay. All right. And a question from Mahmood is, how does the certification work? Is it like once we have finished assignment, quiz and project, we are going to receive a certificate? Yes. So that's a certificate from our side that you have completed. You have completed and learned successfully. If it is mandatory from your organization side that you need a kind of proof of attendance right away, just let us know. We will send you an attendance certificate. Okay. So for attendance certificate, you don't need to finish assignment, quizzes, and projects. But for the proper certificate, you will require one. You will need to finish at least one project. Okay. So that's a hard requirement. Okay. And all right, Pradeep. Let me review it once because we have been continuously improving. The fact is that I have improved the slides since last time. And so yes, let me try to check whether these slides are updated or not. Yes, for Hive there have been a humongous change, so I'll update Hive slides. Okay, I think I did update. Let me just check again once after the session. All right, great, wonderful. Any other questions before we move forward? Good, good. So let's get started. Today's session is going to be very interesting, and I'll try to focus on few things that are quite important and move accordingly. All right. So yesterday we learned something very important. We learned something called Spark SQL, basically the data frames. The data frames make it possible to interact with semi-structured and structured data sources from many places. Okay, so most of the work revolves around data frame as of today. In newer libraries of Spark, say for example, Stanford NLP. Stanford NLP um, is a standard library which converts a string to a meaningful, which infers the meaning of a string. Okay, say you say this is a great class. Now it'll Stanford NLP will understand the sentence and would help you tell that this is subject, this is object, this is verb, and it is a positive sentence, it is a negative sentence, and so on. So those kind of libraries, the wrappers on top of those libraries have been written for Spark as well, and those wrappers are supporting data frames better than RDT. Okay, so data frames, even though they came into play in Spark 2, which is around 3-4 months ago, or not 4-5 months ago, and they have become very popular because they represent structured data, and you can either query using SQL, or you can query and present like R. Okay, so when data frames made it possible to operate like R, so they also made it possible to use the command line for R. So we had Python command line already. Like when you say Python command line pops up, and then interactive shell comes up, and then we code in Python. So so what Spark guys did, they took the existing, they basically launch Python command interpreter from within PySpark, okay, by initializing extra variable called SC. Similarly, Spark shell creates a connection to Spark, initializes the driver, and then launches the usual scalar shell. In a similar fashion, SparkR is kind of a R package that provides lightweight front end to use Spark on R. Okay. All right, let me show you. Okay, so let me give you a quick demo for all these three things which I've told you. Okay. So we have Python and PySpark. Then we have what do you say? Scala. Okay, and we have Spark Shell. We have R, and we have SparkR. Good. So in this, they basically add a driver. Okay, uh, you can say Spark driver, and wrap it along, and that's what becomes PySpark. Similarly, Scala is and then. Or you can say that when you launch PySpark, or when you launch Spark Shell, it initializes the driver, Spark driver, establishes connection, and gives you extra object called SC, and launches usual scalar shell. Okay, it's kind of a quick recap. Let me log in. Let me log into. Okay, let me log into my console. You can log in from web browser, or you can log in from anywhere. Okay, so let's say there was this nice interactive shell called Python, right? This is the usual Python shell. Now, PySpark is nothing but a Python shell with extra variable SC, which is connecting to Spark. This is a connection establishment happening. Okay, so now you have, when you say SC, you have extra object. Everything that you can do in Python, you can do in PySpark, because it's just two extra variables. One is SC, and other is the Hive context earlier. So there are these two extra variables. This is Spark 1.5.2. Okay. and I've already discussed how to launch other versions. Similarly, we have Scala, right? This is a standard usual Scala cell. It has nothing to do with Spark. It does not know anything about Spark. It came far before Spark came into play. All right. So now the same thing was wrapped in Spark shell. Okay. So what Spark shell does is it internally launches Scala. Okay. After initializing those two variables. Okay. So you can see that there is a SC Spark context available. Good. With a couple of extra variables. Make sense to you? Will take a little time maybe. Never mind. So our role here is more related to SparkR. In the similar fashion, you have R. R is great tool. What is R? R is a great tool for analyzing data. While Python and Scala were targeted towards full-fledged programming languages, which can do almost everything, while R was more to do with visualizing, doing statistical operations, and doing machine learning operations using R. Okay, so and R has many packages, and R is probably the most popular language because most popular language amongst data scientists. Reason is that R has got biggest library on statistical computing as well as machine learning and others. Okay, so 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 this is where you generally code in R. And R also allows you to visualize data. In case you want to visualize data using CloudX Lab, in those cases, you will have to log into R using SSH minus X. What does SSH minus X do? SSH minus X brings the UI from remote to your local machine. Okay. So whatever we try to display on CloudX Lab console, it will come back here in this UI. Okay. All right. Now let me try to start R. So here I can let me just pick up one R visualization exercise. Okay. R graphs. Let me just pick up one quick example of graph. Okay. So, all right. So let me just try this example. Here, there is a data set called empty car in R. Okay. And this data set, so right now we are just trying plain R exercise. And we are saying plot WT MPG. Okay. What is WT and MPG? WT is one column, MPG is another column. So in this, it should basically draw the line here. You can see that. Okay. So it has drawn these points on the graph. Okay. Similarly, we have AB line here. So this is another kind of graph. So what's happening is R is running inside e.cloudxlab. The visualization is being pushed to my desktop because while connecting SSH, I used SSH minus X. Okay. For this, if you are on Mac, you will have to install Xquartz. On Windows, you might have to install something else. On Linux, you don't need to install anything. Okay. So this is R. With R, you can do many kind of things. R also has loops, defining functions, and a query language to query language to to kind of query huge data in the form of tables. And this data in the form of tables is called data frame. For example, we have empty cars. So you can see that empty cars is basically a huge data set of cars. You see that? This is the car name, and these are the features of car. Okay. A question from Tegu: how can I see the graph from Putty? That I need to find out because I've not used graph from Putty. There is a tutorial. Somebody has written a tutorial on our blog. Okay, I'll have to find out. There was one here, and okay, so there should be one. All right, I'll have to just take a look at this one. Shows how to connect, and all right. Okay. Okay, I'll have to check. I remember I had made a small video for Mac and Linux, but I don't remember for Putty. Okay, no worries. Let me just make a note of it. No worries. Good. So, all right. So we were able to quickly do some, look at some data sets and do work in case of R. All right. Now coming back to what we were talking about this. Okay. So in the similar way, what Spark people did was they made Spark available inside R by the way of SparkR. So when you start SparkR, internally it launches R along with the connection to Spark. Again, it basically, when you do some machine learning operation using data frame of Spark inside R, then those machine learning operations happen inside Spark. All right. If you do not touch the objects related to Spark, you will continue to use R locally. Okay. All right. So this was SparkR is a package that provides lightweight front end to use Spark on R. It provides a distributed data frame implementation that supports operations like selection as in projection, selecting column and selecting range of columns, and filtering, aggregation, etc. It can handle large data sets. It supports distributed machine learning using MLA. All right. A data frame is a distributed collection of, so in the same way, what we had data frames earlier, yesterday, what we talked about something called data frame. In RDD, we don't know about columns. So what we do is we convert an RDD into data frame by converting every record into a row object, into an object, and then translating that into data frame is very straightforward. So In case of data frame is like a table which has columns and rows, and we know about the data type of every column. So data frame is structured data, is for the structured data, and RDD was for unstructured data, right? So a data frame is a distributed collection of data organized into named columns. It is equivalent to a table in relational database or a data frame in R, but with richer optimization under the hood. Can be constructed from wide array of sources such as structured data files, tables in Hive, and external data databases or existing local R data frame. Yesterday, we demonstrated how we loaded a data from Hive into a data frame. From JSON and XML, we did that. From Avro, we did that. Paraquay also. Along with that, we created a data frame from MySQL. Okay, so that's an important part of data frame in R as well as SparkR. Okay, so same data frame is exposed in SparkR, the one that we studied yesterday. So to launch Spark, we have to launch this way. Okay, so we have to say, because it's a newer version and the one that came bundled with our Hortonworks platform was older, so we have installed a newer version for you, and you can access it here. All right. So that's our SparkR, and let's take a look at it. You can see that it is started, and it is saying that Spark UI could not be bound to 4040. Instead, it has 4042. All right. So good. Now, so we have launched SparkR. In this SparkR, we can do many things. There are data set called Faithful. So the difference is the way we used, what do you say, earlier empty cars. Instead of that, you have to say create data frame. This is the only difference in the operation of SparkR. So what does it say? It says that create a data frame, distributed data frame using Spark from a data set called Faithful. This Faithful data set contains a local example of data of volcanic eruptions. Okay. So this one, all right? So these are the local data for these are data that comes with R. We're converting this data, we're converting Faithful into DF, which is Spark data frame. Once we are done when done with that, we can either say head DF, so it shows you first 6 lines, and if you say show DF, it will show you 20 lines. Okay, DF dot show. No, actually, show DF was right. Okay, we'll have to see why. Okay. All right. I think, yeah, show was yesterday when we were doing Spark SQL and we say df.show. Here you have to use head or tail. Okay. So we can see that we are able to see the same data which was earlier. And okay, so moving ahead. Now we can, instead of using the example data provided by by R, we can also load data from our JSON file that we discussed yesterday. This is our JSON file. It contains the objects. A very good question, Sudhakar. Yesterday, when we loaded this data, right? So it all automatically inferred the columns, right? So it basically, that's a part of library. It goes through first a few records, and then infers the total number of records, total number of columns. It uses that. So it basically goes through the data set and then infers. While parsing this data, when it parses this data and tries to create columns out of it, that time it reads the column headers. It creates the column headers. Okay, good, good. So we are able to load this data from HDFS into our SparkR. Okay, so those people who are from our background, they would be feeling pretty happy for two reasons. One, we are using R. Second, we are using big data on R. And third, we are running the things on Spark instead of running inside R. The challenge that R people faced was when the data started growing a little bigger, it used to get loaded into the memory, and therefore it could not handle a little bigger data. Okay. The other problems that people face in R is, let's say they are trying to do a complex machine learning operation which requires a lot of iterations. Now, in case of R, since everything was happening on one machine, it used to take a lot of time. But in case of Spark, if it's running on cluster, your SparkR can get things done really fast. Okay. All right. So Sudhakar's question is that in Faithful, how were the column headers added? So the create data frame method that we used, it converts the headers to headers of Faithful to DF. All right. It's basically create data frame is a function provided by Spark. It wasn't there earlier. Okay. So if you want to see the schema of our file, this data frame created from this file, then you can just say print schema, and you have name, which is a long as in big number, and age, which is a big number, and name, which is a string, right? So that's and so we could see that we could further try to do some more operation using R. Let's again create the same data frame. Okay. Also, this arrow is equal to equal sign in R. If you are from R, you will know that part. Okay. So we have DF, and we could simply say things like select DF and pick up a column from DF, and then further you can see that we have just picked one column called eruptions. Okay, we skip the other column. Okay, and we could also do things like filter on top of data frame. So we filtered all the data frame where waiting column is less than 50. All right. And further, we could do things like group by, summarize, the usual things that we do in R. Okay, so you can see that. So whatever you could do in R, you can do the same thing with SparkR. All right. Good. So again, we can do operations on columns and other complex operation, like we can load a JSON file, convert it into a table, and then inside the R itself, we can use SQL. So these are the things that SparkR has provided. Spark SQL lets you filter using R kind of constructs, while while SparkR lets you use SQL as well. So there's a complete flexibility in terms of how from where to read data, which tool to use, and which constructs to use. So this gives us a very great power in terms of data analysis or data churning. So all kinds of ETL, all kinds of complex operations can be done using these methods. A question from Jiankun: if I load data into data frame, is the number of partitions decided by number of partitions of the original file? Yes. So based on how big is people.json file, the number of partitions of people would be decided. All right, that's a part of the framework. Good question. Great set of questions. So this was SparkR, and basically this entire session was about how to convert raw data into a data frame and how to process structured data. Okay, so this so far in key value RDD or normal RDD sessions, what we learned was how to process kind of raw data in which we are not too worried about columns. Okay, so here we talked about basically this diagram gives you a very good idea that using data frame you can interact with many data stores and many data types. All right, now let's talk about machine learning. Yes, you can load. Yesterday we did load data from MySQL using a JDBC connection in Spark SQL. Same thing should be possible inside our SparkR. Yes, in those cases, Jiankun, the partition is something that would be hard for Spark to decide. But in those cases, probably you will have to specify the partitions. Very good question. Question is, so we have earlier talked about data stores like HDFS. Number of input splits dictate how many partitions are going to be in the RDD, right? The number of input splits of HDFS file dictates how many uh, partitions are going to be in an RDD, and that was easier. But what if we load data from MySQL? How many partitions would be there? In those cases, you will have to explicitly specify partitions. Okay, like when you're loading text file and sc.text file, and that text file is being loaded from a network file. In those cases, you can specify you can specify a number of partitions that you want. So let's say you are loading. Okay, let's say you're saying sc.text file and you are saying ftp, or let's say http my file, wherever it is, and so on. So here you could specify how many partitions do you want. Okay, similarly, you have a huge data set in the memory. Okay, and you want to say parallelize, right? Parallelize, and this is my local variable. Okay, and you want to convert this into a data RAD. In those cases, you can specify, say, 13 partitions you're looking for. In the similar way, while creating data frame, most of the APIs do provide you with the option of specifying how many partitions are there. If an API does not provide, and at any point you want to create more partitions, you can say repartition. Okay, sorry, the data frame or data set, whatever. Okay, so whatever is your variable, let's say my RDD dot repartition, you can repartition an RDD. All right, so okay, So Jiankun is saying that there is an option while in the read.jdbc. Okay, good, good. And similarly, there is a repartition function in the SparkR documentation. Good. Thank you, Jiankun, to do the little bit of research. And yes, I really appreciate this part. Good, good. So, all right. So basically, you have the flexibility of controlling the parallelization by defining how many partitions are going to be there. All right. Now, a very interesting exercise we all have been doing, been hearing about AI and machine learning. So let's have a brief discussion and maybe do an exercise in order to understand machine learning. Okay. All right. So everybody ready? All right. Good. Good. So here's the definition. It sounds pretty boring, but here's the definition. Machine learning means programming computers to optimize a performance using example data or past experience, right? And it's a branch of AI, artificial intelligence. It's for design and development of algorithms where computers evolve behavior based on empirical data. Did it make sense to you? All right. I know that this sounds a little too much verbose. Let's take a proper, simple example. All right. Let's take a simple example. All right, so how many of you have played Mario? Have you played Mario before? All right. How much time did it take you to learn and win the princess? Princess? How much time did it take for you to learn and win the princess? Never? Okay. All right. All right. So Hung has actually won the princess. Yes. Okay. Okay. Now, question is that do you think the way you learned Mario without any external support, right? Can the program learn to play any game like Mario by itself without anybody explicitly writing code to play Mario? Can a program learn to play Mario by itself? So this guy actually did it. What he did was he launched Mario and as a you know, in case you are still interested in playing Mario, what you can do is you can use these virtual machine kind of setups. Okay, so there are software which are emulators of your console, inside which you can load Mario games data in the form of kind of ISO, and you can play Mario on your PC. All right, these are called emulators. What emulators do is they basically run the same console as in the gaming console, inside a window on your computer, right? So if you're interested to play Mario still, same Mario what you played, or same games like Tank, and there were quite a few games earlier which are very popular and very fun to play, you can still use those. Use a emulator. There are quite a few emulators available as of today. So what this guy did was he ran the console inside this emulator. Emulator is like a software program in which the game is run, and then it basically trained the program. It basically hooked the program to the emulator. So this program was observing emulator. Emulator was keeping the graphics in the memory and was keeping the score for the game at a particular point in the memory. Okay, so what he did was he hooked the program to to the emulator. So the program was observing emulator and sending commands like up, down, right, and spacebar and so on to the to the emulator. Okay, so the program was playing instead of you. It was basically program was observing the score and was randomly pressing the keys in order to maximize score. And program has the access to the entire memory, visual memory where the graphics is kept. Therefore, program could see what is there on the screen. So based on what keys it has pressed, what is there on the screen, and what kind of score did it get last time, it keeps on learning. Okay, it keeps on learning, and that's what uh, he did. Okay, now what you're going to see is something really amazing. So it's a day zero. Okay, it's a day zero. The program is pressing keys randomly, it's going nowhere, and Mario dies of old age. You can see that? Yes. Now, after a little while, the program is slightly moving forward, but it still was facing backwards for no reason. And then it's able to, do a little bit computation, and it is kind of badly stuck and doesn't move. After a little more training, the program is further learning how to play Mario better. So it's kind of figured out how to now jump these hurdles. And okay, please note that nobody has programmed the computer to jump or do anything. The program was told only to play, only to press random keys in order to maximize the game, maximize the score. Now, after a few more weeks, this program, which is playing Mario, it's kind of expert. You can see that it's able to play really cool tricks. Now, what was that? The Goomba fall on it, and still it won. It basically killed Goomba. Okay, so it figured out the weaknesses in the game. It figured out the weaknesses in the game. All right, so you can see this is another bug it's exploiting right now. So now what you see is that it has kind of become intelligent, and it has kind of become intelligence. We did not tell the rules of physics. We did not tell that there is something called colliding. We did not tell what does it mean by collision, or we did not teach that this is called Goomba, stay away from it. This is a duck, stay away from it if it's coming to. We did not tell anything. All we did was do whatever you can in order to maximize your score. Okay, that's what was done as part of this program. This is called machine learning. The program is learning by itself. We have just told the objective, and we have given the data, told the objective, and it's basically figuring out how and how can it win and what keys it can press. In another game, what he did was it hooked the same program to another game, Tetrix, and here it is not able to play it well because Tetrix requires a little bit more effort. So what the game does is what program does is it keeps on pausing the game again and again. Okay, because pausing is not reducing its score. Pausing is keeping the score. Therefore, it keeps on pausing the game. It's like in the childhood when our cousins and siblings did not win against us, they will spoil the game by by throwing around the chessboard. Okay, so in the same way, it's basically pausing the game so that it doesn't lose. All right. So this is an example of machine learning. Did it make sense to you? Okay. So was my explanation clear about this emulation? Did you get it? April, Jiankun, Nitesh, Ravi, Sahida, Samit, Hang, Mahmood, Pradeep, Srini, Tegu, Sudhakar. Was I able to explain what does it mean by machine learning? All right. Great. So yes. So now this definition would make a little more sense. So programming computers to optimize the performance using example data or past experience. So in our example, past experience is previous gameplay and example data is being produced by itself. Okay. And the purpose it was trying is optimizing the performance, as in it was maximizing the score. All right, maximizing the score. So the computers actually evolve behavior based on empirical data. Now these sentences, if you try to fit in the example that we've talked about, these sentences will make more sense. All right. The example that we have talked about is a decently complex example of reinforcement machine learning. Largely, machine learning is classified into three types: supervised, unsupervised, and semi-supervised. Supervised means we have clearly classified data from which it has to learn, right? So you clearly put things into folder and tell that, okay, given newer data, please put the data in the correct folders. Okay, that's called supervised learning. Unsupervised learning is we have no clue about various labels in the data. Instead, we have to predict some kind of output. For example, here are a million emails. Can you just create 10 buckets and put these million emails into those 10 buckets using whatever mechanism you want? Okay, that's unsupervised learning. The other unsupervised learning example is that you are given the features of all the species of the globe. Features as in the age, the height, I mean the maximum age. So for every species, if we have weight, height, and the age, the time, and what does it eat, and all other anthropological features. And you have to do is, what you have to do is, given these species, you create kind of a chart such that chart of a binary tree kind of a chart, such that two elements which are nearer in the chart, they are similar, right? Like for monkeys and humans, you bring them together, you basically will have them together because they are matching in the features. So this is unsupervised learning, given humongous data automatically classifying things into buckets without any labels upfront. Semi-supervised is for some data you have labels, for some you don't. All right. There are many more applications of machine learning, right? So almost every aspect of computing is going to get impacted with machine learning. Okay. And as simple as, let's say here in this, you can see, let's say here, I want to insert a symbol. Okay, so symbol. Okay, so even the Google Docs have implemented, these kind of features where you can draw a symbol. Let's say I'm looking for this kind of symbol. Okay, so it has found that these are the symbols that look like this. You can see that. Okay, you can see these are the symbols that look like what I have drawn. All right, let's say I'm looking for, not this one, I'm looking for something of this sort. Okay, so you can see that these are the symbols it has found. So this also needs decent amount of machine learning. Okay, so almost every kind of computing where there's a lot of information available to you with which you can learn, machine learning will come into impact. Okay, and specifically the complex operation. Okay, so is my voice breaking a lot? Since when? Recently, or it has been breaking for some time? Okay, so Mario game was not clear. Okay, I see. I see. Let me try. So I'm going to give it a try to another connection. Okay. So I'm going to give it a try to another connection. Let me see how it is. All right. Is it any better now? Yes. Great. Okay. So looks like my internet connection is going little unstable. So what I will do is, okay. So looks like my connectivity is unstable. Let me try the third one. Okay. Just give me a second. So hi April, hi Jiankun, hi Nani, hi Nitesh, hi Ravi, Sahida. Is it clear? No, is it breaking? Okay, all right. So as soon as it breaks next time, what I'll do is I'll switch to my 4G connectivity. I hope that'll be better. Yes, let's watch for 1 more minute, and then I have the third one that should work. Okay, looks like both the optical fibers are down, are having the bad connectivity. Okay, so what we have discussed about is we talked about what is machine learning by the way of Mario example. Then we talked about what is supervised learning and what is unsupervised. In case of supervised, we have already classified things, and in unsupervised, we don't have an example of classification. So in unsupervised learning, we do things like mm, put things into bucket automatically based on similar characteristics of elements and so on. That's called unsupervised learning. So there are many applications of machine learning in today's time. Okay, computer vision, natural language processing, speech, and handwriting are classic examples of machine learning that has been going on for quite some time. Now, what are the kind of tools that we use for machine learning? What are the tools that we use for machine learning? Okay, so a very simple task called regression is what? I'll explain. So let us say the other example that would help you understand what does it mean by machine learning is, let's say your salary for 2014 was this much. 2015, it became this much. And then 2016 became this much. Now you're trying to figure out what would be my salary for 17, right? So you will do is you will try to draw a line, right? You'll try to draw a line through it, which is closest, okay? Which is, so where the total distances from the lines are minimized. And this line is giving us the salary, predicted salary for 17, right? Once we have drawn this line. So this data we have up to 2016, but not for 17. So this is extrapolation. Okay, this is extrapolation. So one way is that you draw any line and you start kind of with different slopes, and then keep on trying all kinds of slopes and see which one is fitting the best. Okay, also maybe little shift in all directions. So you can see that when we are trying to figure out that line, the total number of combinations could be really high. Okay, you could have this, you could have this, and move it little into all directions and like this, and then trying to figure out which line is fitting well. Okay, which line is fitting well into these points. So we generally have to iterate over all the lines and figuring out which one is the closest to the actual data. This is called linear regression of single variable. Okay, and this is the simplest example of machine learning. All right, when you have more parameters, here we have just time as a function, time as the parameter for our salary. Salary is on y-axis. What if we had more parameters like the age, the number of hours you were spending, the industry, the kind of what do you say, the experience years, and so on. So there could be many other factors that could be considered while predicting the salary of people, right? So when you have more and more parameters, more and more variables, then you will have a lot of more iterations than usual, and that's why machine learning becomes a very complex task. Okay, a simple linear regression itself would become really complex and would become hard to get it done. So that's why we need parallel computing as well as distributed computing in order to solve machine learning problem, right? Because the algorithms are complex as well as the data is humongous. The more the data, the better would be machine learning, and therefore we cannot skip certain data. Okay, so that's why distributed computing and parallel computing is required, because there's a lot of data as well as computing is complex. Okay. Now, if you had few records like this, you could do it using whiteboard very easily. Okay, draw it on the whiteboard, take a big scale and draw the line, and there you have. Okay, if you have just few data points, then you can use whiteboard. For visualization as well as analysis, you just need whiteboard. But when data goes into thousands of records, right, then you use Excel, MATLAB, Octave, R for processing and visualization. But when the data goes beyond millions of records, okay, when the data goes beyond millions of records, then the tools for analysis and visualization separate out. Okay, for analysis, we will have NumPy, SciPy, Vecka, BLAS, and those kind of tools. While for visualization, you would have Flare, MChart, Raphael, and Protobase. Okay, but when the data goes beyond billions of records, when you have more than billion records for analysis and machine learning, you would not be able to do it using your usual tool. You would need a distributed computing environment. Okay, like Mahout, Giraffe, SparkR, MLlib, and GraphX. Okay, these are the tools required for humongous data analysis. Okay, is everyone with me? All right, did it break my voice? Okay, good, good. So as soon as it breaks, just let me know. I'll switch to another network, this one, and it should be fine. Okay, so this was a general overview of what is machine learning. And in machine learning, the important part is that you don't write too much of code to do actual logic. Instead, you write code to train the computer to do things, to do the actual work. All right. So if somebody is writing code and claiming that it's machine learning, don't buy it. Okay. Because in machine learning, you're supposed to, the machine is supposed to learn. All right. Now, earlier, when before these tools, people used to use, as I was telling you, that NumPy, SciPy, R, those kind of tools were very popular because they provided all the algorithms required for machine learning. Okay, but but as data grew big, it was impossible to use any of those tools like R or NumPy or SciPy because it loaded data into the memory and there was overflow, right? And one CPU could not solve so much of, could not iterate through so many permutations. Therefore, therefore, we needed newer tools which could run distributively, as in which could do the analysis like matrix multiplication and other kind of complex operations on the cluster. So we got Mahout from Hadoop, whereby Mahout could do many algorithms in a distributed fashion. So on the similar lines, while Mahout was operating on top of MapReduce of Hadoop, Spark team created their own library called MLlib, machine learning library, on top of Spark RDD and Spark data frames. Okay, so any data is represented at RDD, and all the operations are done in a distributed fashion, whether computing summary, computing mean, computing standard deviation, computing the linear regression, all of these are done in a distributed fashion. And that's what is MLlib about. Goal is to make practical machine learning scalable and easy. Okay, scalable means it should use multiple computers and without you having to worry about it. Okay, so it consists of common learning algorithms and utilities like classification, regression, clustering. Clustering is automatic classification. Classification is where you have already said that that this photo means a bottle, this photo means a sticky note, this photo means a computer. And then after training a computer with this kind of data, computer will automatically start classifying objects. So that's classification. Regression is regression is the way we computed the salary. That's regression. Clustering is given the species, you cluster them into buckets. Okay, that's clustering. Collaborative filtering is recommendations, right? What is recommendation? You and I sit together, we shared about my movie experiences, you shared yours, and then we started giving movie recommendations to each other. Now, to do this on a larger scale, if we have millions of people, it becomes easier. Okay, so you can algorithm can figure out who is similar to each other and then start giving recommendations. So that's collaborative filtering. Then sometimes we need to remove dimensions. That's dimensionality reduction. That's a part of machine learning. And then sometimes you might have to write your own algorithms. For that, it provides lower level optimization primitives. Okay, like for example, it would provide all kinds of matrix factorization techniques and other ways, other mathematical operations that are required mostly for creating your own algorithm. So sometimes you need to create a pipeline and run the pipeline again and again on data. That's also possible with machine learning, MLlib. Okay, so the structure of MLlib is one part of MLlib is algorithms. Second is pipeline. Third is featureization. Fourth is persistence. And then there are utilities called linear algebra, statistics, and data handling. So these are the 5 parts of machine learning, MLlib library. Okay, let's try to instead of talking about it, let's try to create a movie recommendation based on our data. Okay, so we have data. You remember our ratings.dat file? So we have this file. Okay, we are going to load this as text file, then convert this into data frame. Okay, and then apply movie recommendations. Okay, so we have this raw data. How does our data look? Let's take a look. Okay, I go to lab credentials and then hue. Okay, so again, what are we trying to do? One is we are going to first take a look at what does ratings file look like. Then we will create movie recommendations for 80/20. I'll explain again. Okay, so let's take a look at ratings.dat. Where is ratings.dat? In the data folder and in ML 1 million. Okay, ML 1 million and movies.dat. Good, please pay attention. And you can see that this data looks like binary. Okay, let me try to clear it if I can. Or what I can do is I can just go to the console and say, okay, so I have opened second console. Say Hadoop, FS cat. Okay, and there we go. So this is the file we're talking about. You see, it has movie ID, movie name. Sorry, this is not the file we are talking about. We are talking about ratings.dat. Ratings.dat. Okay, so you can see that it has got movie ID, user ID. Okay, no, sorry. This is right. So this is one file, and okay, README is there. Okay, so README tells about what does it have. First column is user ID, second is movie ID, third is ratings, and fourth is timestamp. This user rated this movie as this much at this time. That's what this file is about. Ratings.dat is about that. Okay, so this user one gave 1193 as 5 rating. Okay, if you go back to the data folder and take a look at movies.dat, you can see 1193, right? 1193. Actually, we cannot search here, so we'll have to take a look at some other way to. Okay, what is 1193? One flew over cuckoo's nest. Okay, so the user number one has given this movie as a rating of 5. So this person one really liked 1193, so it has given 5. Okay, so this way these all ratings are organized. So ratings.dat contains the movie preferences of many users. Okay, and based on this, can we predict movie ratings? So what we're going to do is we're going to break down this data set into 80-20. Okay, this data set into 80-20. All right. Oh, it doesn't work this way. So out of this, what we're going to do is for 80% of the data, from 80% of the data, we are going to do the predictions for 20% of it. So out of this data, what we're going to do is we're going to separate it into 80% and 20%. From 80% of the data, we will learn, and remaining 20%, we will try to do the prediction and then compare with the actual one. Okay, it's like checking if somebody is telling the truth by comparing with the reality, because remaining 20% as well, we know exactly which movies did they like and how much, right? Therefore we will try to predict the ratings of remaining users. Okay, and then compare with the original. So let's do that. Let's try to do that. So first of all, we are going to load this data. Okay. So let's start our Spark shell. Spark shell. Okay. Okay. Let it connect. I'm hoping it will connect. We were supposed to start Spark 2, not this one. All right. I hope everybody's with me so far. So we are trying to do the movie recommendations automatically using this library called MLlib. Okay. So first thing we do is we load the raw data, right? Now what we have to do is we have to convert that into an object called ratings. Okay. You remember the way we did it earlier? We created a class representing our object, then we converted our raw data into that object, and then we converted that into data frame, right? So we are defining rating, which has 4 variables: user ID, movie ID, rating, float, and timestamp. Okay, so we define the class. Good. Then we define a method. What this method does is, for every string, it is going to split by colon, right? Double colons, actually, because the data was actually separated by double colon. And then here we're just checking if the fields are, the number of fields are 4. And then if this fails, it won't move forward. And here we are translating our raw data into ratings object, right? 0th field is user ID, first field is integer, second field is first field is movie ID, first 0th field is user ID, movie ID, and then rating, and then timestamp. Good. Is it clear to everyone? All right. So we have loaded the data. Now we are going to say is raw. Okay. All right. Just give me a second. Looks like Rahela is facing a problem in connecting to CloudXLab. Okay. So let me just extend the. Can you just put your login ID, Rahela? Rahela, can you put your login ID? I don't. I'm not sure. Yeah. Yes. Okay. All right. This was changed. I remember I changed it. Not created it. This is ended. Okay. So I'm extending it till 14th April. All right. So you can refresh it and it should work. Good. Now going ahead with what we were discussing. Okay. So we have raw data. What we're going to do with raw data is we're going to run a function called map. Okay. And then it's going to create another RDD with this object. And then we're going to call to data frame object, to df function, and this will convert our data into the data frame. So those who are interested, I can post this entire code here. And okay, once we are done with creating the ratings here, what we are going to do is we're going to split this data. We're doing a random split of this data into two data sets called training and test. Both of these are RDDs. Please keep that in mind. So both of these are kind of data frames, not RDDs. So training is a data frame. You can see this is a data frame, and test is also a data frame. Both of these are not local. They are basically like RDD. Okay, so we are able to create the two data sets. Now is the time to run the algorithm. Running the algorithm is pretty straightforward. First, create instance of new ALS, because there are many movie recommendation algorithms called, there are many actually. We used a Tanimoto coefficient earlier, at InMobi. I've used that one, and I've used the least cosine one. And here we are using alternating least square, because alternating least square is known to give great results. Here it requires us to set how many iterations do you want. These are the parameters. If you increase number of iterations, the results might improve a little bit. And this is regression parameters. So this is the accuracy you are desiring, and these are the features with respect to every algorithms that you can set. Okay, and then we are telling that our data contains this particular column which has the values for users, and then this column in our data contains the the product, the item, right? Because this algorithm will operate on any data set which contains user ID, product ID or item ID, and the ratings. So that's what we are telling it, that this column is user ID column, this column is movie ID column, and this column is ratings column. Okay, that's what we are trying to do here. And let me paste it to everyone as well, and here as well. So it says that the algorithm is not found. Why? Because I have not imported this. Okay, I have, while copy pasting, I had pasted that part to you. All right, now this should work fine. Let me try. Yes, so it has created ALS. Okay, ALS, which knows how to generate the move. ALS had generated kind of model model for ALS is kind of algorithm which knows how to do things. Now let's do the training. We are saying ALS dot fit this data. So far we have just configured algorithm. Okay, then we are saying this particular line is the one which is doing the actual machine learning. Okay, so here is, okay, so this one could take some time. Okay, so it has created this model. This is the model representing our recommendations. Using this model, we can keep on generating recommendations in future. Okay, so similar at the time, if you have to, let's say you have to do a distributed machine learning, as in you have to generate recommendation on the fly. So what you do is you save this model onto a production server and upload it there. And then you call the MLlib library in your web server whenever there's a request coming from user. So this model remains static, and you generate this model every evening or every third day. Okay, on say I mean the way we were doing it in case of InMobi, we were generating this model using Mahat, and then we were basically doing it every third day. Okay, not third day, every actually 7 days, because this data on which we were training was around 200 terabyte. Okay, out of 200 TB, we were cleaning it up and we were creating something like 20 GB of clean data. Okay, all right, now let's try to do the predictions. So based on the model, this can be run many times. Okay, so we are saying well predictions and model dot predict. Okay, so this is model dot transform is giving us the predictions. All right, so now let's take a look at what kind of predictions it has given. So what you see here is training and test. Training is 80% of total data, and 20% of the data is in the test. Using training, we are building our model, and using model, we are generating recommendations for the 20% remaining data. And this is generally the way we develop our machine learning strategies. Okay, we split our data into two parts, training and test, and then using training, we train our model. and then using model, we generate predictions for the test data. Okay. So you can see that it had generated this. It had generated the results. Okay. You have user ID, movie ID. This was the original result, while this is the newer one, right? So you can see that while actual was 3.0, predicted is 2.927. This is very close, right? Similarly, for this user, this movie ID, the actual was 1.0 as rating, while predicted is 4.1, which is totally wrong, right? Similarly, for this user, the actual was 3.0 and predicted is 3.3. See that? 3.29. Now we can check how efficient our algorithm is by finding the difference between actual and predicted. This is actual, this is predicted. If we find the difference between the two and sum it up, and sum it up as in remove the negatives, and or by squaring it, and then sum it up, then we will get the actual performance of our algorithm. Meaning by computing standard deviation, by computing the deviation, or we call it RMS value, root mean square value. Okay, so we can do those kind of things and check how performant is our algorithm. But we're not going to do it here. Okay, so it had basically generated these predictions. These predictions can be saved into any kind of file. Okay, here we are saving using CSV format into here, okay, which can be used at a later point of time. All right, so there we go. And let's see if it gives error. Yes, it did, because it was already done. I'm going to drop this table. Hadoop fs minus rmr, and all right, let me save it again. So now when we are saving, it's computing again, and then it will save. Okay, it's basically running this again. All right, so let it finish. Yeah, it has done the work. Okay, you can take a look in the results. All right, so till what point have I think this whole thing I have given you. Let me just give this part as well again. Okay, I have given only to one person. Share it with all. Okay, so somebody was facing a challenge with respect to. Okay, so it's giving the error for this. Actually, you have to launch the SparkR in this way. Okay, I'm going to copy paste. So instead of using the default one, you have a Spark shell, you have to launch using this way. Okay, that should be good. All right, is everybody okay so far? All right, so we were able to successfully generate the movie recommendations. Now, exercise for all of you. Okay, create your movie ratings. Okay, meaning I like this movie this much. All right, I like this movie this much. So what you can do is you can take a look at this movie, allocate either 0 or -1 for yourself as ID, or maybe find out the max ID. And so find the maximum user ID for yourself, create the next user ID denoting yourself, then put your ratings on various movies in the same format, and then generate your movie recommendation. You can also do, while you're generating, right, take the original data, concatenate it with your data, right, doing a union. There is a function called union, and then, or you can use some other way. So you can generate the total data set, and on that data set you create the model, and then using that model generate movie recommendations only for yourself. Okay, only for yourself. Okay, so this will be the actual movie recommendations for you, right? This will be the most unbiased form of movie recommendations, because Netflix and everybody would try to give you the recommendations out of the movies they have, or they would try to upsell something else. Okay, but this movie recommendations, if you do it correctly, it will give you the movies that you will really love to watch over holidays. Okay, that's okay. This is not an error. It's just okay. Sudhakar, yeah. Okay, so once you're done, you write down your steps in Google Docs and share with support at Novik Data. All right. So this is a good exercise, and I strongly recommend that everybody does it. Okay, one, it'll give you a great set of movies to watch over the over the summer vacations, and it will also give you the good experience of trying to do movie recommendations. Okay, and whenever big data machine learning comes into play, most of the work is recommendations. Okay, so this would give you a very good starting point. Okay, so this was a quick overview of machine learning, right? There are quite detailed things as we go ahead. So I'm going to skip a lot of things because it requires a little more background on what we are trying to do. So Spark MLA provides you the basic data types such as vectors, points, and matrices. Okay, vectors, points, and matrices. Just like it has provided a new representation for array, in the same way, it provides other basic constructs, making it possible for you to do machine learning in more efficient manner, as well as providing you a way of writing your own algorithms. Okay, it also provides pipelines, so you can create pipelines. This would go into little beyond what we had discussed, so I'm going to skip pipelines a bit. Okay, with respect to basic statistics, Spark provides all kinds of basic statistics needed, like summary, correlation, sampling, and then hypothesis testing, random data generation, and kernel density estimations. Okay, so those kind of um, algorithms are also provided by Spark and can be executed on humongous data. All right, so all right. So we have already tried mean, variance, and things like that. So basically, the statistical inference is also very well supported at MLA. Those who are interested, they can take a look at their individual algorithms and run through the examples. Okay. This is the place where it has provided the details about classifications. So you can try their examples. That should be good enough. Okay, all of the data sets that are provided by Spark guys is also available on CloudXLab. Okay, in the same folder inside Spark. All right, so there are many classifications and regression techniques. Classification is putting things into various buckets. Okay, and regression is drawing a line and trying to fit a line into the data, right? So that's regression. And so there are many kinds of algorithms available to do the regression. Okay. So collaborative filtering is recommendations that we have used already. And we have used ALS to learn these latent vectors. Okay. So clustering is this: given, say, many data points, you can cluster them into various buckets. All right. There are many other clustering techniques. There are many algorithms for clustering. One is k-means, Gaussian mixture, PIC, and LDA. You can take a look at these and try to go into more details, because machine learning itself is kind of more than 50 hours, of course. Okay, so you can try the k-means example here. All right, and I think that'll be a little too much here. So I think this you can try by yourself. So what we're trying to do is, given a certain data, we want to create groups amongst data. And when we use k-means, we specify how many groups exactly do we want. Okay. So we are saying that here we want to group our data into two groups. Okay. And this is our data. So all we do is first clean this data, create a clean data, and then run this data using k-means. Okay, and that's all. Okay, so you can try the same algorithm in Python is here. Okay, and here we are trying to compute the efficiency of our algorithm by subtracting the original with actual and so on. Okay, so there are all kinds of algorithms available as part of MLA. All right, we will do one more exercise on graphics, and that should be good. You want to take a break? Okay, let's take a break for 10 minutes. Okay, so let's take a break for 10 minutes, and we'll be back by 9:52. All right. So I'm back. Should we start? All right. If you have any questions, please feel free to ask. I'm sure you will be having questions. Okay. So far, we have discussed today basically we learned about SparkR today, and we also learned about machine learning and ML. Okay. All right. So let's start. It's 9:52. Any questions before we start? So yes. Now we'll be discussing GraphX, and then we'll talk about the project assignments, and then that'll be it. That'll be it. All right. Good. Good. So yeah. One of the very important data structures in computer science is graph. Okay. A lot of things, when we talked about Google PageRank, for example, we try to compute the Google PageRank by assigning various values, right? That Google PageRank, the relationship between pages was represented as a graph, right? So when there are more than one entities and there is a relationship between those, they inevitably form a graph. Okay. For example, here we have Franklin, I Stoker, and I don't know, I don't even know how to pronounce their names, and uh, I Stoica, and J Gonjal, and R Exin, and so these are the four people, right? And two, which is Stoica, is following Franklin. Franklin is a colleague, or you can say he's a colleague. That's the relationship between 2 and 5. While uh, 7 is basically having another relationship called PI, right? Here, personal something. Okay, and so on. So we have collaborator, advisor. Those are the relationship names. Now, so this is one example of graph. This is one example of graph. Okay, you can represent this graph as a vertex table or edge table. Okay, edge table means source is 3 and then destination is 7 and the property is collaborator. So this is the definition of edges and this is the definition of vertex. Okay, this is the definition of vertex. So these are independent vertex and these are connected by edges in this following manner. Okay. So when these graphs become bigger, it becomes impossible to use an in-memory computation to solve this. It's impossible to use a single computer for these kind of complex graphs. This is where GraphX comes into play. GraphX is a library. GraphX is a library provided by Spark. Okay. It's basically for doing the graph computation on humongous data. Okay, out of all the libraries available, GraphX has been the clear winner so far. Okay, it basically extend under the hood. A graph is represented as an RDD. Okay, meaning a graph is distributed. Okay, so you can do a lot of graph operations using GraphX. Using Spark with the help of library called GraphX, we could do a lot of graph-based operation, such as very fundamental operations, such as finding whether one graph is a child of another graph, as in kind of a subset of another graph, and then join the vertices, as in merge multiple graphs, and aggregate messages. Okay, and basically aggregating graphs, that's all. And then there are quite a few clever libraries being added to GraphX. One of them is PageRank. With PageRank, you can compute who is more important in a graph of objects. Okay, based on how many pages are linking to you, you can figure out which page is important, what is the rank. So if more pages which are important link to you, you are more important. It's as simple as that. And then there are these another very important algorithms called connected components, meaning connected components as in mm, what are the various uh, you know, the clusters amongst your friends and how are those clusters connected with each other. Then the triangle counting. Triangle counting is how many triangles passing through each vertex. Okay, this is again for measuring how dense is clustering. Okay, so next is label propagation, SVD plus, and strongly connected components. So far, GraphX is only available in Scala. All right, so let's take a look at this diagram. Okay, the example we have is this one. There are how many? 3 plus 3, 6 persons, and there is a relationship between these. So so 2, which is Lady Gaga, is following Barack Obama. Barack Obama is following Lady Gaga. Justin Bieber is following Barack Obama. And we have this another graph where Matty is following John Racine, and Martin is being followed by John, and vice versa, and the relationship. And the seventh one is Anonymous, which is being not followed by anybody and is not following anybody. Okay, so now we have to compute their ratings. Okay, we have to compute their page ranks. So it's actually pretty complex because you have seven nodes, right? And there's a relationship between them. So what you have to do is you have to initially give them each one rating, the page rank as 1. Okay, and then what you do is you compute the page rank of any element. Let's say page rank of 1, right? This one. So page rank of 1, any node is 0.15. That's a kind of fixed number. 0.15 plus 0.85 multiplied by the rank of each page. Okay, rank contribution of each page. So contribution of each page into 0.85. So Lady Gaga and Justin Bieber is contributing to Barack Obama. So the contribution of Lady Gaga is going to be a rank of Lady Gaga divided by 1, because it's only giving the following Barack Obama. So is only giving its rank to Barack Obama, and so on. So that way, when you compute the ranking, it is going to take a lot of time, because if the graph is bigger, it's far difficult to get it done using one computer or doing it manually. That's where the Spark GraphX comes into play. Let's launch Spark Shell. Okay, we are on Spark Shell already. And then what we're going to do is we are going to import it. So I'm going to copy paste this to all of you. All right. So before jumping into it, let me also show you how does the data look like. Okay. So we go into data, then Spark, and then we say here there'll be which data are we churning here? We are churning data, graphics, and followers. Okay, data, graphic, Spark graphics, and followers. So we have users. Okay, users contain the ID, name, and full name. Okay, ID, handle, and name. Now here in followers, we have basically just numbers. Who is following who? You can see that. 2 is followed by 1 and 4 is followed by 1. Let me see, does it mean correct? 2 is followed by 1 and 1. Okay, here it is. So 2 is following 1, 4 is following 1. 1 is following 2, 6 is following 3, 7 is following 3, 7 is following 6, 6 is following 7, 3 is following 7. Okay, so nobody is talking about node number 5. Okay, so sorry, node number 7, I think. No, it is 5 actually. 5 is not being followed by anybody. This is, I think this is 5. This is 7. This is 7, I think, and this one is 5. Okay. All right. So now what we do is we first import the graphics. Okay. Simple. Then we simply load this graph saying this is the list of edges. These because A following B, that's an edge. Okay. This is one edge, second edge, and third edge. Okay. And so we are going to load the edges. So we are saying this is the edge list file and this is the data file, and we are creating using Spark context. All right. Then we are going to say, okay, so here it is basically computing the page rank. Okay, you can see there are quite a few iterations that have gone in this. And once you're done with the ranks, okay, you can see, and you can say rank.show, or not show, we have to say ranks.collect. So you can see that the ranks contain the information about the rank of everyone. So 4 has got 0.5, 6 has got 0.7, and so on. Okay, so till here everything is finished. You get that? That's all. All right. Now further, what we are trying to do is we are trying to load the users and attach the username and show the details with the name rather than ID. Okay, so this is the situation. All right. So this is the outcome of PageRank. So this is the outcome of PageRank after the computation. Good. All right. Did it make sense to you? So if you basically download all your Twitter followers and their followers up to like 4 level or 3 level, and that should be good enough. That should be good enough to give you a very decent page rank. Yeah, nobody is following Justin Bieber. So what will happen is 0.85 into 0, right? That means the remaining Justin Bieber's rank will be 0.15. Correct? Okay. So, all right. So, Samit's question is, how do you interpret the stats? As in here, you can see that 1.46 means out of all these people, Barack Obama is the most important person, then Lady Gaga, and then Martin Odersky, based on this data. Okay. And least important is probably Justin Bieber. All right. Same here. When you, in the last, we are printing the details. It is showing us Justin Bieber is 0.15, and this. Okay, do you mean this one? Did you mean that how do you interpret the statistics here? All right. I think that I was able to answer, right? Even here, you can see this is the array of, you know, the 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 ID and the rank. All right. Okay, great, great. So we were able to successfully do the page rank. So if we had some good data on Twitter, who is following who, we can actually figure out who is the thought leader, who is more important. As of now, most of the people try to figure out who is more important to Twitter by dividing followers by followed. Okay, that way. But PageRank is more more important, um, you know, more important criteria than the dividing followers by followed. So this was GraphX. GraphX provide these beautiful libraries for doing the graph computation on humongous graphs. Okay, all right. So that was our discussion on GraphX and machine learning. All right. So there are these projects. One project was Weblogs. Okay. Second is sentiment analysis. Let me explain what does it mean by sentiment analysis. Third is movie recommendations for yourself. Okay. All right. So here, the one of the assignment is this one is a very simple assignment. It's basically about how should I say? It's basically for unstructured data. You have to clean up the data and do the statistics required. Okay. So here we are saying that write Spark code to find out 5 time frames of least traffic. Okay. So go through these questions and you should be able to answer. I think Samit has already submitted this part. Okay. So one is this assignment, and second is the sentiment, Twitter sentiment analysis. Okay. Second is Twitter sentiment analysis. So as part of this project, you have to compute real-time sentiment of tweets for any keyword of your choice using Spark Streaming. Okay. Here, the post is outlining an approach using Stanford NLP. Okay. So what you have to do is you have to compute real-time sentiment of tweets for any keyword of your choice using Spark Streaming. Okay. It's a little hard project than as compared to what it looks like, because it involves almost everything what we have learned so far. Okay, so we're going to use Stanford NLP. It's an NLP tool which is quite popular and is giving a very good results. Okay, and just follow this blog what we have put here, and that should be good enough. Okay. All right. So go through it and try to understand what does it mean. And if you get stuck, let me know. So what we are going to do here is first we are going to, create a connect. There is a connector for Twitter for Spark Streaming to Twitter. Okay. Let me give you a good diagram here. So we're going to use Spark Streaming. Okay, there will be a Twitter connector. Okay, Twitter connector. So using Twitter connector, the data will come to Spark Streaming. From Spark Streaming, we are going to use, in this Spark Streaming, we are going to use the Stanford NLP. Okay, and then we are going to save it. uh, you know we are going to save the results, or just print the results, and that's it. Okay, so it's that way. So go through this one, it should be good enough. You can do visualization of your own choice. Here, I mean, you can use Socket.io, D3JS, or just print on the screen. If you could just print on the screen that that what is the sentiment per second, or per minute, uh, how many positive and how many negative tweets, or maybe per hour, how many negative and positive tweets about a particular keyword. That's all. Okay, so this is the second project, sorry, and this is the third one, movie recommendations for yourselves. Okay, all these three projects are available in session 18. Okay, and go through those. All right, any questions? Okay, a question from Sudhakar. Will you be giving an overview of MapRFS? So what is MapRFS? MapRFS is basically enterprise tool from a company called MapR. Okay, it is based on HDFS and is compatible with the APIs. So yeah, so I don't have more information because I've not used MapRFS myself, but it is basically based on similar to HDFS, and it provides a network connector so that you can mount it like a drive, or you can connect using SMB and so on. Okay, like network file system. All right. Internally, the architecture is similar to what HDFS is. So that is MapRFS. You can say that they took HDFS, improved it, and made it enterprise grade, and offer it like MapRFS. All right. So that's a quick one. I would not be going into much detail. I would say that you follow their documentation for knowing more about it. All right. So that's, I think, pretty much for the course. All right. So we have understood what is big data. We also learned tools like Zookeeper, then HDFS, then Hive, and Big, and HBase, NoSQL. We also learned the various tools like Scoopflume, Uzi, and then we talked about Spark. We understood how to do processing using Spark, using RDDs. Then we used a high level construct like the data frame. We also did Spark streaming, using, I mean, processing data in real time using Spark. And then we did a, right. Then we basically learned about MLlib and GraphX, and also about Spark SQL and SparkR. Okay, so that was pretty much with respect to the course. And if you are facing any difficulty, let us know by dropping an email at support at NoBigData. Okay, support at NoBigData. Okay, and avoid sending mail to Sandeep at NoBigData, because I'm little, overwhelmed by emails. So I hardly check my own inbox, but I do check the support inbox. Okay, so or there are other people who look into there is one, Abhinav, who is one of my access students. He is taking care of my support inbox as well. So so uh, it's better to send email to support at NoBigData instead of Sandeep at NoBigData. All right. All right. So feel free to reach out to us at any time at support at NoBigData. And if needed, if still you need a help on one-on-one, I would love to do that. All right. So feel free to reach out, and I mean, whatever is possible, I would love to do that. Okay. All right. So the way with no big data happens is that it doesn't make sense to say goodbyes because we are going to stay connected anyway. All right. So feel free to send me a LinkedIn request. Stay active on the Facebook students group. And if you have any questions, queries, or anything, feel free to drop us an email. All right. So yes. All right. All right. Thank you, Srini. Thank you, Hang. Thank you, Sudhakar. Thank you, Ravi. Yes. Yes, Ravi. And actually, this group is available in this here. I'll show you. So I think this is the group. You see, join Facebook group. All right. And feel free to connect with me on LinkedIn. So no, this course will be available to you lifelong. Okay. We will try to make it available for as long as possible. If needed, if let's say we are closing No Big Data, moving to CloudX Lab, then I'll let you know in details. Okay. CloudX Lab will be up to 14th of April. Okay. All right. My LinkedIn profile is there a LinkedIn profile somewhere? Okay, let me share my LinkedIn profile in case. How do you share the LinkedIn profile? Is it listed somewhere? Here. All right. So that's my LinkedIn profile. So feel free to connect with me. And yeah. All right. So it was a great session. I had wonderful set of questions from the batch, and I'm very happy to know about the backgrounds of the team. And I look forward to stay connected. All right. So thank you for having a wonderful session, and I really enjoyed the questions. All right. So thank you, April. Thank you, Kar. Thank you, Nitesh. Thank you, Ravi. Thank you, Shahida. Thank you, Shamit. Thank you, Mahmood. Thank you, Pradeep. Thank you, Srini, Tegu, and Sudhakar. All right. You can share your LinkedIn profile on the email thread that has everybody, so that yeah. All right. So thank you, everyone. Bye bye. Have a great week ahead.